Okay, we want to add another component to a graph. And don't let it feel like it's too complicated. It's just adding another problem to it. And if we just keep working the problems backwards, we'll get to where we need to go. So this graph, the new one I have a y equals 4 times sine, or 4 sine of a 2x minus 2 pi 3. So we see this new little component inside the function that we have here. And with this extra part right here is called a phase shift. And so what we're going to do is we're going to take our graph, whatever graph that we come up with, and we're going to shift it left or right depending on what that phase shift is. So the basic function that we have, if we looked at the basic graph, we have some amplitude times its sine. Inside the parentheses, we have a bx minus a c. Where that b we discovered earlier that helped us determine what the period of the graph is. And then this C right here represents some mechanism to help us discover what its phase shift is. So let's start working through and discovering what we have available to us. First of all, its amplitude. We know its amplitude is 4, so that will help us out on the graph. Let's go and mark it 4 at the height and -4 at the low. So we can go ahead and cap it out. So now we have our amplitude. The second part that we want to discover is we want to figure out what's its period. Where does the graph, where would the basic graph start and where would the next cycle continue from? So we find that out by with this value right here. That value is 2 pi divided by the b. So I have a period of pi. And let me just put that right there for now. So we know that the graph repeats itself, or the function repeats itself every pi radians. Now it's phase shift. A phase shift means that it's not going to start where we thought it would start. It's going to shift and it'll start at a different point. So that's going to help us out by taking its c over its b. So its c is 2 pi over 3 over its b value, which is a 2. And if I reduce that down, that gives me pi thirds. So what that tells me is its phase shift begins at pi thirds. So rather than starting here at 0, it's going to start over here at pi thirds. The next part we need to do, just uses a little bit of algebra, is we want to find out where are those 4 key parts of the graph at. So what we do is we take its entire period, which we found out was pi, and we divide that into 4 sections. So we know that something cool happens every pi fourths. Now, in our previous graph, that was pretty easy. That would be 0, pi fourths, pi halves, 3/4 pi, and pi. However, where it becomes a little bit difficult this time is that our starting point is at pi thirds. So the next interesting part of our graph happens pi fourths beyond pi thirds. So I have to kind of figure out where some of those points are at. So let me do the first one for you, and we'll kind of get a sense of what's going on. So I need to take pi thirds and add to it pi fourths. Common denominators, that's going to make it 4 pi over 12 plus 3 pi over 12 gives me 7 pi 12ths. So the next interesting part of my graph is going to be over here at 7 pi 12ths. Okay, let's add another 1/4 pi to 7 pi 12ths. Same process that we'll get over here, and then we're going to get a 5/6 pi. Add another pi fourths to that. I'll get 13/12 pi. And then we got to find one more 1/4 pi mark past that, and a 1/4 mark past that one's going to give me 4/3 pi. Is that what I came up with? 4/3 pi. Now, when you do your homework, you're going to have to go ahead and do this algebraic sequence every single time. We took our period, which was a pi. We divided it up into 4 equal sections because we know that every fourth of this period something cool happens. So we took our beginning point, which is our phase shift, and then we added what's the first unique part happening. All right, since this was our beginning point, we know that the graph crosses right there. Let's change colors. We know that it crosses right there, crosses right here, crosses right there. The first one, since it was a positive amplitude, we know that it's going to go up first. So this first marker is a maximum. This marker over here is a minimum. So now I have a graph that so there's the graph of 4 sine quantity 2x minus 2 pi over 3. And again, just to kind of recap what we did here, I know there was some magic going on. So once you kind of get rid of the magic, what we did is we discovered what its amplitude was. And that was an easy thing. Let's always start with the graph with something that's easy. So we put its amplitude, which is our maximum and our minimum values. The second part is we discovered what its period is. It's not 2 pi in this case. It's this value 2, which is divided underneath the 2 pi. So the period was constricted just down to over a period or a length of pi. So we had somewhere of pi. And then after that, we had this phase shift, which took the regular graph and shifted it all over to the right. And I found my phase shift by taking my value of C, divided by my value of B, my value of C divided by my value of B, which gives me a new starting point. And that new graph starts at pi thirds, and then I just add quarter marks past that point to figure out where all the key parts are at. Now this is going to take some practice, so I really encourage you not to skimp on your homework problems that you have to kind of unpack this. And this is kind of cool stuff. And it's cool because it's doable. So go get them, guys.